right, should we get started? Good afternoon, everyone, and welcome to the talk on building great network media devices for apps that implement the Play 2 contract. It's great to have all of you here today. I wanted to start by introducing myself. My name is Zain Salim. I'm a program manager on the Windows Media team, and I've been working on Play 2 through the Windows 8 release. In fact, I joined Microsoft 2.5 years ago, right out of college, and I worked on Play 2 for Windows 7. So this is pretty much all I've done my whole career, so it's great to be here talking to you about it. At the keynote a couple of days ago, you heard about how Build is the launch of an opportunity to build great apps for Windows 8. It's also the launch of an opportunity to build really awesome devices that work really well with those apps. So at this talk, we're going to go into some of the specifics about how you can build devices that work really well with Play 2. Also, I should mention, I'm here with Edwin Heredia, who's one of my colleagues, and he'll be going through the second half of the talk. And I'm sure he'll be introducing himself when he comes up here. So the agenda for today is really three things. I wanted to start out by walking you through the Play 2 experience in Windows 8. So we're going to start with a series of demos. And then we're going to flow into how it works, really what is going on the PC, what is happening on the device, how is this communication happening over the network. And finally, we're going to talk about the certification process for a Play 2 device that helps us ensure that it works really well with apps and our scenarios from the Metro style experience. Hopefully, you'll walk away with a good understanding of what it takes to build a really great, high-quality device that ensures a reliable consumer experience that really blows our customers away. So to start out, I wanted to ask a few quick questions. How many of you have heard of Play 2 or used it in the context of Windows 7? So that's about half the room. Okay. Have the rest of you seen any of the demos at the Expo Hall or somewhere else over the last few days? Anybody that's seen that? A few, too? Okay, great. Well, it's great to have you here because we've made a lot of great improvements to Play 2. The work we did in Windows 7 allowed customers to stream media from Windows Media Player and Windows Explorer to their home media devices. And in Windows 8, we've really worked hard to open that up to Metro-style apps in the form of a Play 2 contract. With just a few lines of code, developers can enable the Play 2 experience in their apps, which is really awesome, and I'll show you some of those in a second. We've also worked hard to make it possible to Play 2 media from the web. Through some of the work we've done in IE10, you can actually navigate to a website that implements the video tag. So any HTML site that uses media, you can stream that to your devices without the developer having done any work at all, and that works today. Thank you. So, all right, without further ado, let's jump into some of our demos. So we're at the Windows 8 start screen, which I'm sure you're all very familiar with at this point. The first thing I want to show you is the experience to add a new device. So this is the new Windows 8 control panel. It's got a bunch of options. It's very easy to use. Worked hard to make it really simple to do fairly complex operations. So this is our Devices tab in the control panel. And to add a device, it's as simple as tapping on Add a Device, and we find your devices, and you can quickly add it. And like you can see here, we've discovered a ton of devices because it's a fairly big network. We've also done a lot of work by which Windows 8 automatically adds devices on a home network. So if you're in a home network, we automatically find media devices like your TV and your speakers, and we add them to Windows so the customer doesn't even have to go through this step. And that's covered in greater detail in another session, which we'll point to at the end. So once you have your devices on your computer, the next thing you want to do is be able to stream them, right? So let's walk through that experience in the context of a few apps. So here's a Photos app that we've been working on. It lets you consume photos from a variety of sources, including SkyDrive. For this demo, I'm just going to walk you through some local photos. So here's a bunch of albums. Let's say I want to go into, there's an album here that I like. An album on surfing, right? So this is a typical photo album. It's got a really great experience. You can quickly browse through your photos. You can select one, go into an all-up view. And now if you want to do a Play 2, how does that work? Swipe in the charms, top-level UI. It's as simple as selecting devices. So as you can see, this is waterfront real estate in the world of UI, right? Right there, your home devices. Let's say you select your family room TV, which in this case is a Western Digital receiver, a little set-top box, and your photo streams to your TV. It's as simple as that. You can navigate, select other photos, and those will continue to stream. So while that's streaming, let's say you want to try sending some music. So let's go into a music app. So this is another one of the apps we've been working on internally, and you saw this in the keynote as well. Let's say I want to listen to some Viper Creek, right? So like any media app, you would select the song. I like that one better. And if you wanted to play too, it's the same consistent workflow, right? Swipe in the charm, select devices. And in this case, I would select my family room speakers, which is this Onkyo AVR right here. And just like that, your media streaming to your AVR. And once that's happening, you can use your local app as a remote control. So if you wanted to pause, it's as simple as tapping, pause, right? So in this case, the developer who built this app didn't have to do any extra work to enable that functionality. I can tap again on the control to play. I can seek, right? And I can do a pretty fine-grained seek, too. I wanted to... So that's a pretty cool experience, right? Some apps that implemented the contract with about 5 lines of code, and now I can stream photos to my TV and music to my AVR. So let's look at some videos now that we've seen music and photos. Let's disconnect that. Let me go into my video app. So I've got a couple of HD videos here. Let me select the paragliding one. Now I swipe in my charms, select device, and you notice I don't see the audio receiver. And the reason for that is because this audio receiver can't consume videos, right? So we do the work to filter to just the devices that are actually supported for the type of media. So let me select my family room TV. And just like that, this HD video is streamed to the device. This video happens to be H.264, which is becoming a very popular format. If I wanted to disconnect, let me switch back to my laptop for a second. Again, it's the same consistent workflow. I swipe in the charms, go into devices, and disconnect. And the frame you're seeing here is the paused version of the last frame before the streaming started. So we kind of pause the video, we continue to show that last frame locally, and stream the rest of it to the device. So that's how it works. Really simple, really easy to do, both from a consumer point of view and from a developer point of view. Let me pause that. So the last demo I wanted to show you was Play 2 from the web, which actually works already, and you can try this out from your Nike tabs. If you have a device that is supported in the build, and Edwin will talk about that later, you can actually go home and Play 2 from any HTML5 site that has a video tag or an audio tag. This particular site I'm using for this demo is our IE Beauty of the Web site, which kind of shows how hardware acceleration and all of that is built into the video tag. So let me select a video here. So this is an HTML5 video, right? So it's playing locally. The developer has done no work besides just built this website like they would any other website. Swipe in the charms. Again, the same consistent workflow, right? And I select my family room TV, which in this case is a Western Digital set-top box. And that's all I have to do. And the video in full HD begins streaming to my device.
Flying cars, personal robots, houses on the moon. Back in the year 1960.
Again, pause and play controls, continue to work just like they would, right?
By 2010, but no one back then could have predicted the impact.
Project that out so everybody in the room can see it.
Just as 50 years
Looks
ago,
pretty good,
no one
right?
could have foreseen what the world would become today, there are endless possibilities for the web's future. Soon, the websites you...
Same experience. If I wanted to disconnect, I just swipe in the charms and I disconnect. So easy to add devices, Really easy to invoke the experience, and it works from a lot of different media, right? Both from the web and from apps. So we're really excited about this, and hoping we'll have the chance to work with a lot of you to build some really awesome devices. So going back to the slides, and to quickly recap what you just saw, what you saw was a setup-free experience, right? You don't have to turn on Play 2 or media streaming. It just works. It's built into the HTML5 audio and video and image tags in IE10. We have working audio, video, and photo apps today. They're not in the image yet because they're not ready for broad distribution, but they do work, and we play with these every day back in Redmond. And finally, it's really easy to support in the apps many of you were hoping will write. It's called the Play 2 contract. It's about 5 lines of code, and we have some reference material on our last slide. So with that, let me invite Edwin up, who's going to walk you through how all of this happens, right, from apps to devices. Thank you.
Thank you, Zaid. Hello, everybody can hear me? Yes. Okay, thank you so much, Zane, for that. Those demos were amazing, actually. I'm really happy and surprised to see that it worked so well. Thank you. So my part of this presentation is actually to tell you a little bit about the technologies and the protocols that these devices use in order to establish communications with Play 2. So let's go ahead and let's start. Okay. There are two components in a Play 2 communications. One is the source, and for the purpose of this presentation, I'm going to call this the Play 2 controller. These devices are normally called controller devices. On the other side, we have the receiver devices. So for the purpose of this presentation, I'm going to call these devices Play 2 receivers. So in order to establish communication between these two endpoints, there are a series of protocols that need to be implemented. The protocols that are implemented have been standardized. There is an organization called the Digital Living Network Alliance, or DLNA, that has selected the protocols that need to be implemented to establish this type of communications. So what I want you to remember is that these devices are implementing DLNA protocols. And this slide is showing actually the collection of protocols. The protocols can be classified or categorized in those 2 file blocks that you can see here. The top block shows the basic connection protocols. And these, the controller, the Play 2 controller, as well as the Play 2 receiver, they implement conventional networking protocols like Ethernet. They can implement Wi-Fi. They can implement both. In addition, in Windows 8, all PCs will support Wi-Fi Direct. So what that means is if you find devices that also implement Wi-Fi Direct, we will be able to do Play 2 over Wi-Fi Direct. And why is that important? Why is Wi-Fi Direct important in this scenario? And I'm just going to tell you my personal experience, why I think Wi-Fi Direct is important. Imagine, for example, at home I have a home network, and I have a home network where I have 3 PCs that have content. I have a couple of TVs that are connected to my network. And imagine I invite some friends to come home, and one of them brings one of these nice little tablets. And they come to my home and they say, hey, Edwin, I have actually pictures from my trip that I did to Mexico. Do you want to see them? I will say them, yes, of course, let's all watch those pictures and let's project those pictures on the TV. So this tablet supports Wi-Fi Direct. I don't want to, although it's my friend, I don't want to give my friend access to my home network. I don't want to give him my password, yes, because it doesn't sound right. But with Wi-Fi Direct, we can actually do a direct connection between the tablet and my TV, and we can watch the pictures there. So that is actually the importance of Wi-Fi Direct. The second layer in this slide set shows discovery and description protocols. So the moment you actually take this device and you plug it in, this device goes through TCP/IP protocols, DHCP protocols, and it acquires an IP address. At that moment, this device is ready for communications, yes? So the discovery and description protocols say that the moment a device is connected to the network, the device has to advertise, has to send some multicast messages to the network saying there is a renderer device and it's available for use. So we use those discovery messages. Play 2 uses those discovery messages. The Play 2 controller uses those messages to know when these devices connect to the network and also to know when devices disconnect from the network. So discovery is very important for those reasons. The second block also says description. And description means it's a small protocol that basically allows the Play 2 controller to ask these devices for a description of their capabilities. So these devices send an XML document and they enumerate the things they can do and the services they provide. So if you want to implement the devices and description layer, you have to go to the UPnP website and get the standard that it's called UPnP Device Architecture version 1.0. That is the basic standard that describes the device discovery and description. Okay, let's go to the third layer. The third layer says control protocols. That layer is the most important layer, but at the same time is the most complex layer because of the number of messages that go back and forth between Play 2 receivers and Play 2 controllers. There are some simple messages. For example, the Play 2 controller can tell this Play 2 receiver, set the volume level to 70. That's a very simple message, control message that goes back and forth. There are more complex messages. For example, there is a message that allows a Play 2 controller to ask for the metadata of the content that it's currently playing on the TV. So the TV has to respond with an XML document saying the title is this, the actor is this, the director is this, and so forth. So all those messages for controlling devices are part of the control layer. If you want to implement the control layer, the basic document is called the UPnP AV Media Renderer document. It's a specification from UPnP as well. The next layer is the streaming layer. And streaming is about 2 things, yes? The first thing about streaming is how to deliver the bits in a timely manner. And the second thing is how we can do trick modes using streaming protocols. The DLNA has selected HTTP as the main streaming protocol. And there are some extensions, there are some extra headers that DLNA has added in order to enable trick modes in the streaming protocol. So in order to implement the streaming layer, we need to read the HTTP 1.1 specifications, and we need to know about the DLNA extensions to HTTP 1.1. The final layer is media formats. When a Play 2 controller talks to a TV, for example, they have to know what media formats can be played. And the DLNA organization has actually accumulated and has defined a list of identifiers that are used exactly for that purpose. So a Play 2 controller can query the TV and ask for the formats that the TV can play. So if you want to know about those identifiers, the standard that you have to go and read is called the DLNA Media Format Guidelines. Okay? This slide is more or less showing the same thing, but it's showing using the typical layered stack. So this shows actually an illustration of a stack that gets built in a Play 2 receiver. At the bottom layer, you have the physical layers, Wi-Fi, Ethernet, and wireless. And at the top layer, you have the application layer scenarios, yes, like in this case, media decoding. So what I want you to see in this slide is that big box in the middle. That big box in the middle is the control layer. Remember, I said that the control layer was the most important, but at the same time, the most complex of all the layers. And in order to implement the control layer, these devices, they have to implement 3 services. One is the connection manager service, the other one is the AV transport service, and the other one is the rendering control service. If you want to implement those services, you go to the UPnP website, you look for the AV media renderer specification, and you find the specification for connection manager, for AV transport, and for rendering control. Okay, finally, in order to describe actually how these technologies work, I wanted to give you an idea of how a simple play-to session works. Yes, remember, Zane actually pushed the play-to button here, and he was able to send video from the tablet to this Western Digital device that I have here. So let me show you actually what messages go back and forth between those two. So at certain point in time, the play-to controller sends a message to the TV or to the Western Digital box or to this Onkyo device and asks what are the media formats that you can play. The device sends back a list of formats. For example, this Onkyo device sends back things like, I can play MP3, I can play WMA, I can play linear PCM, and a series of things. So the play-to controller knows actually the formats that you can play. Then a user actually is browsing content from the web or browsing content locally and selects some content. And then the user actually invokes Play-to, pushes the button that says Play-to. At that moment, the controller sends a URI for the content to the TV, and the TV will make an HTTP request asking for the content bytes. The controller sends the content stream, for example, for video, and the TV starts playing immediately. There is no need to download the entire content. You get just a few data packets, and the TV can start playing back the content. So content is flowing from the controller to the TV. At any point in time, the user can actually send special actions for pause, stop, and seek. So that's the very typical session that happens between the controller device and the receiver device. From an application perspective, one of the achievements actually that, in my opinion, are very important to notice is that it is very simple to add Play-to functionality to applications written in JavaScript, okay? And this slide is trying to show that there are only 3 steps that have to be followed. Step number 1 is you have an application, and your application can do media consumption. So step number 1 is to create a Play-to manager object that it's going to handle these Play-to operations. Step number 2 is to register that Play-to manager object to receive events from the UI. So when a user actually clicks the Play-to button, that event will actually reach your Play-to manager. Yes? So that's the second step. And the third step is that when an event happens, when a user is actually clicking the Play-to button, you want to tell us which of the media components you want to stream to the device. So following those 3 steps is sufficient actually to implement Play-to in applications. Okay. We're going to change a little bit the context of this presentation right now. And we're going to talk about certification. In order to, so this is what we're going to do. all of us here actually are love technology, and we either work with software or with hardware. But in order to think about this part of the presentation, what I want you to do is to forget a little bit about technology, okay? Don't think about software, don't think about hardware, and put your hat of users. So we all are users now. We don't know about technologies. We don't know how the protocols work. We are just users that want to use the Play 2 feature. So we want to go to a store, we want to buy a device, and we want to use Play 2. And we don't know about protocols, we don't know. So I have two questions for you, and I want you to think about those two questions. Question number one is, if you think as a user, you've seen the Play 2 demonstration, what is your expectation about Play 2? So tomorrow you actually take your tablet, you try to do Play 2 with a device that you just acquired. What is your expectation as a user? The second question is related to the first one. And the second question is, as a user, what things you don't like if, in a Play 2 scenario? What things would actually really drive you crazy and motivate you to make a call to either Microsoft or to the companies that are building these devices? What are the problems that would prevent a really nice, smooth experience? Yes, and I can think several problems actually about that, yes? One of the problems that I can think is, imagine if tomorrow I'm trying to do Play 2 from my nice tablet, and I get an error either here or here that says unknown media formats or incompatible media formats, yes? Or perhaps the next day I get an error that says error 0x2ABC or something like that. Users absolutely hate that, yes? So the question is, how do we prevent that? How do we provide that user experience that will actually make this Play 2 scenario compelling for everybody? Not only for people that understand technologies, but also for people that don't understand technologies. And that's what we want to examine here in this part of the presentation with your help. Okay, and I think actually there are two critical components to build good products that users like. And one critical component is about protocols. We have to implement the protocols correctly. Yes? Let's see. I'm sure many of you have worked on implementing protocols. And I think all of you will agree with me that it's very easy if I write the protocol for the server and I write the protocol for the client. That normally works well, yes? No problems. The difficult thing, the challenge here is if a company like Microsoft writes the protocol for the server, and another company like Western Digital or Onkyo writes the protocol for the client. If you're familiar with the DLNA protocols, hundreds and hundreds of pages that are referencing other standards. So it's very hard to accomplish actually that full protocol interoperability. So the question is, in that scenario, how do we make sure that devices implement the protocols correctly? Fortunately, we have an answer. We have an answer because the DLNA organization has a very rich, very well established certification program. So you can actually, if you build software or you build hardware and you take your device to DLNA, they will actually run a series of tests, hundreds of tests, to actually check if the protocols are working correctly. So in order actually to have good products, the first step that we would like to recommend is that you actually go through the certification program that DLNA has, because they will test for protocol compliance. But that's not enough. That's not sufficient. It's necessary, but it's not sufficient. And it's not sufficient because of user experience. you can have devices that implement protocols very nicely, but devices that have a very poor user experience. And then things will go to the wrong way again, yes? Let me give you an example, actually. There were some devices that implemented the protocols correctly, but each time that you send play to, each time you hit the play to button here in the controller, some devices require you to answer some question here, or they require you to push some button here before they can accept the communications. And I think it's okay to do it once, but if a user every time has to go and basically touch some buttons on the device, then that becomes a user experience that, as a user, you're not happy with, yes? So protocol compliance is just one aspect of a good product. The second product is about product quality, user experience requirements. So at Microsoft, together with a few other companies, we have been thinking about what defines a good product, what defines a good user experience for the Play 2 scenario. And we created a series of tests, and we can give you those tests. We can make those tests available to you, and you can run those tests and check your devices if they actually meet those guidelines or not. We call that the Windows Certification Program for Network Media Devices. So that is actually our solution to define what is a good product, to try to design devices that really match user expectations. I wanted to pay attention also to the first line of this slide, yes? And I want to go back to my user question. When a user hits Play 2 here, the expectation from that user is that Play 2 will always work, yes? Because the expectation is that Play 2 always works, in Windows 8, in the list of devices that you can see on the UI, we will only show devices that have good quality. In other words, we will only show devices that pass the certification program. Okay, let me give you some examples actually about these user experiences, product quality. These particular examples are about usability, performance, and quality, as the title says here. But I'm not going to actually look at what the slides is saying, and I want to talk to you about only bullets number 2 and bullets number 4, sorry. So bullet number 2, and let's make a thought experiment with you. So tomorrow, for example, we buy one of these tablets, and we take it home, and you put your collection of pictures into this device, and maybe you have 1,000 pictures, and you put those pictures on this device. And then you hit Play 2 for one picture, more or less what Zane did, yes? He had pictures, he hits Play 2 with one picture. How quickly do you want that picture to be on the TV? Who would be happy here if it takes 30 seconds to go from that, to move the picture from this device to the TV? No one, yes? Who would be happy with 0 seconds? Everybody's happy, yes? So we have to define a proper balance. We have to define what is reasonable for users, what is an acceptable latency for users for sending images, for sending videos, and for sending music. We would like to be 0 for usability perspectives, but we understand that for technology reasons, it's not possible to be 0 for many devices at this time. So as part of our usability requirements, we are trying to define what is the expected latency for specific types of content. So that's about bullet number 2. And about bullet number 3, or number 4, I'm sorry, I think you will agree with me that the industry, starting 5 years ago or maybe even more, is moving towards this modern set of formats. In terms of video, that means H.264. In terms of audio, it means AAC, low complexity audio. And normally, everything is encapsulated in MP4 containers, yes? So we think, actually, 1, 2, 3, 4 years from now, people will have more and more access to this type of content, H.264, AAC, and MP4. Yeah, I think actually users will have this type of, well, cell phones. They will have also cameras. And all these devices can actually capture content in these formats. So if I am a user, I put my pictures, my videos on my PC, and I want to send those to my TV, to my Western Digital device, or to my Onkyo device, I want that content, the content that I have, to basically play on those devices. That's why we need devices to support H.264, AAC, and MP4, because those formats are becoming very common, yes? So, this is just another slide trying to show similar examples. And these examples are about consistency, reliability, and completeness. And again, I'm just going to talk about one of these bullets here. And the one I want to talk to you about is 1, 2, 3, the fourth bullet. And I was thinking actually that the best way to explain the fourth bullet is with an example. I'm sure everybody has used YouTube, yes? When you use YouTube as a user, you know that you can play content, you can stop content, you can pause content, and you can seek content before or seek to future positions, yes? So as a user, users expect to have a complete set of transport controls when they use YouTube. So as a user, when I buy these devices, you expect to have the same level of functionality, yes? You want to see these devices to being able to do play, stop, pause, and seek. So that particular guideline, that recommendation that we have for the industry is we want the industry to implement the protocols that are necessary for those control types that are extremely popular and that we all as users want to have in our devices, yes? It's not right anymore to implement devices that only do pause and play, but they don't do seek. We want devices that actually do the whole set of transport controls available. Okay, so this is a little bit like a recap of our certification program. And the things that I would like to remember about certification program are, first, users or customers, like the first bullet says. Yes, the certification program, what it's trying to do is we're trying to define what's a good user experience. We're trying to define devices that users will be happy with and they will be able to use Play 2 all the time. So the first bullet is about users. The second bullet is about applications. I'm sure many on this room are actually thinking about writing media applications, and they may be considering adding Play 2 to their application. As an application developer, you want your application to work with Onkyo, Western Digital, Sony, Samsung, any type of device, yes? It doesn't make sense to write an application that works well with device A, B, C, but it doesn't work well with D, E, and F. So the certification program ensures that application developers can write the same type of code, and the same type of code will do Play 2 with any type of devices. That, we think, is the second advantage of having this certification program. The third bullet is something that I haven't talked about, but it's like a bonus material for you to consider. When you're certified devices, they have the ability to download content from a service that Microsoft has at any time. And the content that comes from that service is designed by device hardware manufacturers or software middleware manufacturers. So Microsoft doesn't design what content gets downloaded. So in other words, for example, if you build an AV receiver and this AV receiver is certified, tomorrow you may want to download a nice looking icon for your device. But if you make changes to the design, 2 months from now you may want to download the new icon, or you may want to download software upgrades for your device. So there is an option that it's available for certified devices to use this Microsoft service to actually bring content from the cloud, content that will enhance somehow your device, and you decide what's that content. Okay. So the developer preview version of Windows 8 that you all have access to now has been designed with the idea that Play 2 will work with certain devices. And so I'm sure you want to actually go and test Play 2. What you need to know is that the way the developer preview is built right now, it's working, it's optimized to work right now with those 3 devices that you can see there. So the only receivers that you can test Play 2 right now, because it's optimized to work with those receivers, are this little box here, that it's a Western Digital device. This box. Okay. The second one is Windows 7 certified Onkyo receivers, and this is an Onkyo receiver. And the third type is Windows 7 and Windows 7 and Windows 8 Windows Media Player software. Okay. There are also a number of apps that are starting to add a Play 2 capability. Zane already showed you how you can use Internet Explorer to browse HTML5 websites. Content that is encoded in H.264 can be sent to devices using Play 2. The conference app that many of you have been using actually to find presentations and find the slides and all that has Play 2. So you can actually use that app. And there is also another app that comes in the build, and it's called NoteSpace, that allows you to create notes and integrate images and videos. And that also supports Play 2 right now. And we think in the future, the developer community will be building more and more apps with Play 2 there. Okay, so as a final recap for the presentation, I think that the things that I would like you to remember 4 months from now, for example, is number one, users or customers. Yes, I've been saying that word over and over again, but users and customers, we want them to actually enjoy media and be able to transfer content to their devices. And so we're designing for users and for customers. We want to optimize the solution for them. The second thing that I want you to remember, and you've seen that in Zane's presentation, that in Windows 8, Play 2 is very easy to use. Yes, it's just a flip of your finger, you can find the Play 2 button to actually send content to devices. The third thing, which for me is actually the most attractive and most interesting one, is that users will have the ability to open Internet Explorer, navigate to HTML5 websites, and push content to their devices. That, for me, is a great scenario. And they can do the same thing from Metro-style apps, and that is just about application developers thinking how they can use Play 2, and I think that will be also an awesome scenario. Okay, a little bit of call for action. Developing this experience is not a Microsoft thing. We all need to build the right devices. We all need to build the ecosystem that will allow our users actually to enjoy this experience. So please partner with us to develop a compelling Play 2 experience for Windows 8. If you are building devices, or if you're building middleware for devices, please design and build these devices to work on media from the web and from Metro-style apps from Windows. And again, if you are building devices or building middleware for devices, start thinking about the certification program. We will help you to actually get the specifications and get the tests, and you can start actually playing with those tests and seeing how your device behaves with those tests. There are several related sessions to this topic that you may want to go and see. I have a list here. And we also have actually 2 white papers that will explain much more than Zane and I were able to do in this hour of presentation. So please look for those 2 white papers that we have. And there is, of course, related the developer type of information here at the bottom of the slide for your help. Well, thank you very much, actually, for attending this presentation. That's all for me. Thanks. Okay. So with respect to DRM support for protected content, Play 2 is optimized for user content. So content that users are sharing over the web, content that users are capturing with cell phones and cameras, or with their Slate cameras as well, yes? So Play 2 has been designed actually for that type of content. Because of that, there is no support for protected content in the Play 2 model right now. The second question was about certifying applications. Applications actually, they are using the Play 2 infrastructure that it's built into Windows. So because of that, the burden is really on us to make sure that those applications will work correctly. So right now, we don't have plans to actually do that. We think actually that our components, as long as you use our components, our APIs, the application should be able to behave correctly. The DLNA actually offers software certification, yes. So you can actually take a whole component and go through DLNA and get it certified. And as you saw in my slide, that is extremely important to ensure protocol compliance, yes.
At home, I have a big PC, desktop PC with tons of storage in it, videos and music and stuff. I have my small little tiny flash drive in my tablet and my TV. And I know DLNA will do a 3-box scenario where you can play to the TV from the storage and control it from my tablet. Is that part of the plans for Windows 8?
Yes, that's the plan. Actually, it's we didn't have the opportunity to show you that. But in Windows 8, servers show up in something that we call the file picker. So when you actually look at the files that you have on the tablet, you will see the files that you have on servers on your home. So if you just pick those files, you will be able to do Play 2 the same as with local content.
And that works in Windows 7 currently? Is that true?
That works also in Windows 7, yes.
The second question I had, I'm sorry. Do you have to have Windows Media Player open and running on any PC that you want to either play from or play to? So Windows Media Player in Windows 8 is just the rendering component. So if you want to render content on your PC, content that maybe I'm sending you from my phone to your PC, then you need Windows Media Player. But if you are sending content from your PC to other devices via Play 2, you don't need Windows Media Player on that PC. It's separate from Windows Media Player. Okay, thank you.
Yeah.
So under Internet Explorer, will you be able to send things like network-based content? So like if NBC has a show up on their website, will you be able to play to that to a TV set?
As long as it's as it is unprotected content using the formats that are defined in HTML5, we should be able to send that content to TVs. Yes.
HTML5 doesn't support protected content on the web, so if there's any content on the web that's an HTML5 audio video, it already works with Play2.
Right. Okay.
What about gaming? Can you use Play2 as a gaming to stream from, like if you're playing a game on your tablet to your TV?
The answer is gaming is a much more complex process because it requires zero latency and full interactivity. And so right now that's not in scope, yes.
I think he partially asked my question, which is there's a much better user experience, since you were talking about user experience consistently, in simply doing Wi-Fi display, and then every app developer doesn't have to integrate all this. You're basically mirroring the experience, and that works on everything. Is that something that's going to actually be announced later on, so we can skip the implementation and just focus on that? Or should we integrate this and then?
Well, that's an interesting question. So we've actually optimized for like just streaming media, because Wi-Fi display is optimized for like a host of scenarios other than media. And turns out it doesn't always work very well with media because doesn't support HD media, and also there tends to be a latency in a lot of the current implementations. But what we've done is we've focused on like a great implementation for like photo slideshows, music and video, and something that delivers a high definition and high quality experience across the board.
So performance is the reason not to do it?
Yes, performance and also just the quality of the experience. Because now you can do things like build a tailored experience where you can have controls on your remote, on your slate, and you could be reading about, like say, the movie you're streaming, or there's a whole host of things you can do on your slate as a secondary monitor, rather than having the same thing on both devices. I think we're out of time, so we're going to be taking more questions. We're happy to talk more. We're going to be on the side, and there's more folks from the team as well. We're also set up at the expo hall, so at around 5:15 we'll be moving over there, and we can even walk through some of the experiences with you if you're interested.
Gabe, where do people need to go to for the Ask the Experts session?
Yeah, so at, what time, 5?
5:30.
Yeah, so starting at 5:30, where everyone eats lunch, the big tables and whatnot, there's an Ask the Experts session. And so everybody, all the speakers from the whole week are going to be there, and there's little sections where you can go, and so we can answer any questions you have in general about media or Play2, any of these questions. There's some great content, questions about content protection and things like that. So we're happy to answer all those questions there as well.
And please remember Gabe, because he will be there. And if you have questions about this session, I agreed with Gabe that he will be there. Yes. So.
Thanks a lot for your time. It was great to have you guys here. It was a great audience. Please come ask us more questions. We're going to be on the side.